Hello, welcome. Let's try to solve another Leetcode problem. 1833, maximum ice cream bars. So the problem is just straightforward. We are given a cost array. So the value just means the cost of this ice cream. So for example, for the zeros ice cream, the value is 1. For the index 1 ice cream, so the value is 3, and then the value is 2, 4, and 1. Maybe the index 2, 3, and for index 4, so the value of the cost of the ice cream is 1. And we are giving this kind of coins. It means we have a value of 7 coins, and we want to buy the ice cream as much as possible. So the straightforward way is that there must be a greedy idea. Yeah, we always want to buy the ice cream with the less price, as less price as possible, because definitely we don't want to buy the most expensive ice cream. We always want to buy the least expensive ice cream, because we want to buy the ice cream as many as possible. Yeah, if we have 1 and 1, definitely we want to buy this one, and this 2, and this 3 first. Yeah, so how many of them? 1 plus 1 plus 4 plus 3, it is 7. It means we need to have a cost of 7, and we buy the most ice cream bars, which is 4. Yeah, so for the next one, it is 4, and we don't have any coins, so we cannot buy it. Yeah, so straightforward idea is the greedy idea, and it is by sorting. But we cannot solve the problem by the quick sort or bubble sort. We have to solve the problem by using the counting sort. So I think this problem is a very good opportunity for us to practice what is counting sort. Yeah, so let's just review what is counting sort. So the counting sort idea is just like the bucket sort. But for counting sort, we can prepare some bucket like that. We can prepare the bucket like the index, like 0, 1, 2, 3, and 4, and 5. So the index just means the value or the cost of ice cream. So for example, how many zeros? I mean, how many ice cream which the value is 0? There's no, because the cost I should always be more than and equal to 1, less than and equal to 10 to the power of 5. Yeah, so definitely we are going to start from the index 1. So how many ones? So there are 2. Because this one and this one. How many 2s? There's 1. And how many 3s? There's 1. And how many 4s? There's 1. Yeah, so this is our array. Now we're gonna loop through this array to check what is the maximum ice cream bars we can buy. Yeah, so this is exactly like the greedy idea, because after we're using the counting sort, we're gonna use the index to represent the cost of each ice cream, and the value gonna be the numbers of the ice cream we can buy if we have enough coins. Yeah. So let's just check one by one. We have 7 coins. Of course, we can buy 2 ice creams with index 1. So we bought 2 ice creams. So our value gonna be 5. So our coin is gonna be 5. Next, we can buy 1 ice cream. So our value gonna be 3, and the count of the ice cream is gonna be 3. Yeah. Because we have a value of 3 coins, and next this ice cream, the cost is 3, so we can buy this one. So 2 plus 1 plus 1, we can buy 4 ice creams. So what is our cost? It is 0, because for the next one, if this is 0, it's less than the index 4, and basically it means we cannot buy any ice cream, so we're gonna return a number of 4. So this is exactly the counting sort. Yeah. Now let's just try to use the counting sort idea to solve the problem. First of all, we're going to prepare a frequency array, so it's going to be 0 times 10 to the power of 5 plus 1. So this is because the cost is more than or equal to 1, less than or equal to 10 to the power of 5. So we're going to use the index to represent the cost. So we're going to use this kind of idea to represent all the costs for the ice cream. Now we just need to loop through the cost array. So for say in costs, and the frequency array, we're going to put this say inside plus equal to 1. Yeah. So now we prepared our counting sort array. We just need to use the counting sort idea to solve the problem. Yeah. So for I in range, so we're going to start from 1 to 10 to the power of 5 plus 1. Yeah. because all the value of the core is going to be more than equal to 1, less than equal to 10 to the power 5. So we're going to, yeah, we just need to check this kind of array. Yeah, so for me, I always give a big value enough because the maximum value is going to be 10 to the power 5. Yeah, so I have to prepare 10 to the power of 5 plus 1. Yeah. Now, I want to have a final count array. Maybe I have prepared a count. This means how many ice cream can I buy. So finally, I'm going to return this count. Yeah. Now, I want to check the costs. I want to check the cost. So if my cost is more than or equal to I currently here index, but actually it is the cost of this ice cream. Yeah. So for my cost, if it is more than I, definitely I can buy at least one ice cream. But I don't know how many I can buy. So I'm going to prepare a minimum array because I want to check what is the what is the ice cream I can buy. So it's going to be the minimum of the frequent array with with frequent I. It means maybe I have too many ice creams. Maybe for this frequency array, so for example, this is 1. Yes, the index I is 1, but it is 100. But we only have 7 coins. How can we buy 100 ice creams? We cannot buy so many. So we have to limit it and by minimum of the coins and divided by the cost. It is I. Yeah, so this is going to be the minimum. And our count would plus equal to this minimum. And after that, how many coins how many coins do we have after we buy this kind of ice cream? Yeah, how many ice cream did we left behind? So the coins, we're gonna update the coins array. It's gonna be minus equal to the cost I times the minimum. It means this minimum just means how many ice cream bars did we buy for the cost of I, for this cost I. Yeah. So this is left behind. If it is still more than or equal to the next I, so we're gonna check the minimum and we're gonna count it and we're gonna check this cost array. Yeah. So else, if this cost array is less than I, basically it means from here we cannot buy it. If we cannot buy it, we're gonna break the array, break the loop immediately. So we're gonna break it. And finally, we just need to return this count array. Now let me submit it to check if it works. As you can see, it works and it's pretty fast, and the time complexity is O(n). Because for coding sort, the time complexity basically it is O(n). Thank you for watching. See you next time.